This is a classic missed middle school opportunity. Graph inequalities, it's pretty straightforward until you start getting into negative x. If x is greater than 2, all the solutions are anything greater than 2. So starting at 2 with an open circle, we're taught to shade in the rest of the number line. Okay, easy enough. And we're also taught that if x is greater than and equal to 2, then we fill in the circle because 2 is included. Again, pretty straightforward. Now here's where it gets interesting. What if I had negative x is greater than 2? Negative x is also called the opposite of x. So if x is greater than 2, the opposite of x must be over here. If x is 2, this is the opposite of x, but it's got to be greater than 2. So it doesn't make a lot of sense yet. So far, this is all pretty confusing. It's much more understandable if the opposite of x was turned back into x. So if I can just multiply through by -1 or switch the sign, then if I switch both signs, then we're good, right? So now we're left with x is greater than -2, and it looks the same as x is greater than 2, it's just that now we're starting at -2. Why is that wrong? So is 0 a solution to x is greater than -2? Well, if I plug in 0, is 0 more than -2? Yes. Is -0, which is 0, is 0 greater than 2? Well, no. So that's confusing because this is how I graphed it. This is the original. Here I reverse the sign from the original problem. Now it says x is less than -2, which is what this set of solutions shows. And you can see that it's basically a mirror image over 0. It's flipped, which is why the rule of flip the sign is accurate, because it creates the set of solutions. Because if I choose -3, negative of -3 is +3, and +3 is greater than 2, and here -3 is less than 2. So kids, it flips, not just the sign, but the visual. So think about that.